Hi, math friends. We're going to look at our review for our systems of equations here. So first we have to draw an example on each graph. When we have one solution, we need to remember that they intersect at one point, right? So we call this the break-even point. We might have called it the point of intersection. So that's what we're looking for. So just drawing an example, you could draw any two lines as long as they intersect once. So I'm going to use my ruler, draw two lines nice and straight with it. So this is an example of one solution, and these two lines intersect right here. An example of no solution, so this is where they do not cross, so they are parallel. So I'm going to draw two lines that are parallel. You could draw them any way that you like. I'm just going to go ahead and draw them slanted this way, some negative slopes, but making sure that they are parallel. Infinite solutions, this is where they end up being the same line. So for this, I'm actually going to go ahead and draw a line with the pencil. And perhaps you drew another line. I'm going to go ahead and use a marker here. And what you notice is that the second line that you draw, it's right on top of it. So it's the exact same line. All right, kind of hard to see with just a pencil or just one color, so they're both right on top of each other there. All right, moving along, we're going to go ahead and graph these. So I want y equals mx plus b. And with these first two equations, we do have that form, right? So this first one, m is 1/3, b is -3. Now remember that 1/3 means up 1, right 3. Let's begin at -3. And then move up 1, right 3. Do it again, up 1, right 3. And we would go off the graph doing that again, so I'm going to do the opposite. Down 1, left 3, down 1, left 3, and go ahead and connect those. So there's our first one. But remember, we got a system, so we got two equations here. So slope here is going to be -1, because there's a -1 in front of the x. And intercept is going to be 1, because of the positive 1. So start here. And I'm going to move down 1, right 1, down 1, right 1, down 1, right 1. Now we found right here, this is our solution. Down 1, right 1, down 1, right 1. We'll draw our line through. We've already found our solution here, but we will still finish graphing this. And our solution is right here. So our x value is 3. Our y value is -2. Next one, same idea, except we don't have mx plus b right now. So we're actually going to have to do a little bit of work here. So this first equation, I'm going to write over here. And we're going to do some work to make it into mx plus b. Now, if you run out of room, it's fine to do this somewhere else, or even take a separate sheet and attach it. Remember that this negative out here is -1, so I'm going to distribute that to both. So I have y minus 3 is -1x minus 2. -1 times 2 is -2. Now I want to get just y. So I'm only going to do plus 3 and get y equals -1x. -2 plus 3 is 1. So here I got m equals -1, b equals 1. Plot that over here. Start at 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. So remember that a whole number we put over 1 to do that. Down 1, right 1 again. Okay, and I'm going to do the opposite, up and left, up and left. I'm doing this because we don't have that second one graphed yet. This is our first line. So hopefully they intersect nicely for our solution. Draw that through. Next equation, this y plus 1, I'm going to go ahead and rewrite it down here. Equals 3x plus 2. So distribute. 3 times x is 3x. 3 times 2 is 6. All right, and do -1. So y equals 3x plus 5. So from here I got m equals 3, so 3 over 1. B equals 5. All right, so I go up 3, right 1, but I start at 5. All right, up 3, I go off that. So I'm going to go down 3, left 1, down 3, left 1, down 3, left 1. That's all we can do there. So we'll go ahead and connect those using my ruler to make this nice and straight. Be proud of your work. All right, and let's find our solution where they cross. So my x value for this is -1. Y value is 2. I'm going to put it right there in that solution box. All right, our next skill is to solve a system using substitution. So if I'm using substitution here, I need to sub something for something else. I'm going to notice I have y equals for each of these. So 3x minus 1, I'm going to substitute that for y in the other equation. So I simply have 3x minus 1 equals -x minus 5. If you need to write it in, please write in a -1 here. All right. Now I'm going to remove the x's that are lower. So I'm going to remove the -1x. So plus 1x, plus 1x. I always like to do that first. So 4x minus 1 equals -5. Remove this -1, plus 1, plus 1. 4x is -4. Divide by 4, x is -1. Now I got to substitute that back in to get y for one of these two. I'm going to choose the second equation. You could choose either one. So if I do that, I get y equals -1 minus 5. Opposite of -1 is 1. 1 minus 5 is -4. So my final answer is -1, comma, -4. Right? You could have used this first equation as well, so we're going to take a second to do that. Y equals 3, use -1, and then minus 1. 3 times -1 is -3. -3 minus 1 is -4. So either equation that you use, I want you to see here, you get -4 for y either way. It didn't matter which one we used. All right, the second one to solve here, I get y equals 3, y equals 2x minus 13. So similar here, right? I know that y is 3. I'm going to substitute 3 in for y in that second equation. 3 equals 2x minus 13. I only have a variable right here, so now I knew some inverses. Add 13. I get 16 is 2x. Divide by 2. 8 equals x. So 8 comma, actually, this first equation already says y equals 3. So 8 comma 3, done. All right, now we got this word problem. We got to write equations from here. So this one, there's a little bit more work to do, and you're going to want to have a calculator. All right, as with anything else, I highly recommend that you go ahead and follow some steps, but then pause it if you're working on this and you really need that extra help, right? Because we want to make sure that we understand how to do this. All right, so this is a bicycle company designing a racing bicycle. They have a design cost of $2,100. Each bicycle will cost $35, and then they're going to sell it. They're going to sell each bicycle for $210, right? So we want our equations to be like y equals mx plus b, right? So when we think about this, the total cost to make the bicycle. So to make it, each bicycle costs $35 for material and labor. So it's $35 for each to make them. They also have to pay a design fee. All right, same thing for, they're going to sell the bicycle. So the income to sell the bicycle, little typo there, but we got it. Okay, 210 each. So 210 each. There's no extra fee. It's just 210 each. So we're going to move to our table. I'm going to use those equations here. 35x plus 2,100. And the income, 210x. Now we're going to use the input of the number of bicycles for x here now. So 35 times 0 plus 2,100. 210 times 0. Okay, so I have 2,100 here. Here we have 0. Our profit, remember, is income minus cost. So I have 0 minus 2,100, I have negative 2,100. And that makes sense because if we don't sell any bikes, we've only lost money. How about 2 bikes? 35 times 2 plus 2,100. And then my income, 210 times 2. So I get 2,170. Here I get 420. Yep. And if we subtract them, we get negative 1,750. Now we'll do 5. And so on for the rest. I highly suggest at this point that you pause this, do some work, and then check it. And then continue with the other inputs too, and you will be all right. All right, so after you're done with that table, we got some questions here. What is the break-even point? So this is where we're looking for the profit to be 0, right? So right here, we're actually going to find it right here. So we're going to rephrase this question. The break-even point is, and we're going to use the coordinates, 12 for x, comma, 2,520 for y. So we got those. I'm going to go ahead and highlight them right here. 12 for x, 2,520 for y. Because both outputs, both y values were 2,520. Okay. What are the cost and income at the break-even point? So we're going to rephrase that. The cost and income at the break-even point are, and they're both the same, 2,520. Okay. Last question on here, part C. What is the profit from bicycles at the break-even point? This is pretty much the same answer for any break-even point. Actually, it is. The profit at the break-even point. Check out your table and check out the meaning of a break-even point is 0. All right, we do have another backside here, so just a few more to do here. So here we got multi-step equations or variables on both sides, however you like to say it. I always like to do that line down the equal sign, and I'm going to subtract away the smaller of the x's. So I'm going to take away a 3x. You can do it the other way too, it doesn't matter, but we'll get the same thing as long as we do the math right. So I get 4x here. Right, subtract another 3. I get negative 10 is 4x. And I got to divide. So I get negative 2.5 equals x. Important for this one, directions up here say tell whether each equation has one solution, no solutions, or infinite solutions. So we can even write one solution. Right? So same thing for 8 and 9. Maybe another step here. So we got these parentheses we have to distribute. So I get 6x minus 9. And I have a little plus 1 on the side. Other side I got 5x plus 10 plus x. So now on this side I got to combine like terms. Remember, we can only combine like terms on the same side. Okay? 6x, negative 9 plus 1, so minus 8. 5x and an x, that's 6x, so plus 10. So you can do this either way. I like to take away the x's first. I do a minus 6x. When I do that, I get a negative 8, I get a 10, but now there's no more x's. So here's where you need to do a little bit of thinking. Does negative 8 equal 10? No. We're going to use this little slash here, means not equal. So there's actually no solution for this. No number that we put in for x will make this a true equation. Let's try number 9, same idea. Distribute. So 2x plus 6, and I get this 6 plus on the front. Remember, I can't put those together first. 6x minus 24, add a 4. Now I got to put together like terms if I can. 2 times 3 was 6, so put these 6's together. 12 plus 2x. Over here, 6x, negative 24 plus 4, so I get a negative 20. All right, now I like to deal with the x's, so minus 2x. I get 12. I get 4x minus 20. So now we have solving a linear equation as we would normally. Do some inverses. Do another inverse. We get x is 8. So we do have an answer here. And we only have one answer, so we also have one solution. All right, so remember, go back, pause, whatever you need to do, work on this, get some extra practice, and you're going to do just fine.